Okay, so a to the power 2 simply means a times a. A to the power 3 simply means a times a times a. And this is obviously just a. So we realize that when I start to move from a power 1 all the way down to a power 3, I'm simply just multiplying by a one more time. What if I go the other way? Yeah, I'm simply dividing by a. I divide by a. I divide by a. And we look on the left hand side, we've got a power 3, become a power 2, become a power 1. What is logically the next line? A power 0 equals to 1. Okay? So this is one way to look at it. Now, we also learned negative indices, okay, in this chapter. So this is 0 indices. The power is 0. That's it. Regardless of the value of a. It can be 1, it can be 10, negative 1, negative 8. As long as you power 0 it, what will we get? 1. You get power 1, yes. Okay? Let's look at it another way. What happens when I take 6 to the power of 8 divided by 6 to the power of 8? What do you think I will get? What do you think I will get? 6 power 8 divided by 6 power 8? 1, right? Okay. Why am I telling you this? Let's talk about indices now. 6 power 8 divided by 6 power 8 is supposed to be our second law of indices. Do you remember? We get 6 to the power of? Which is? 6 power? 0. Do you see that these are the same? So doesn't that mean that this must be equal to this? Yes. So what is 6 power 0? 1. What's 10 power 0? 1. Yeah. Get it? Yes. Did you all already know this? Yes. No, okay. Let me change my question. Did you already know this way of explaining it? Yes. Okay, for those who did not know, are you happy now knowing that you get it? Yes. Yeah, I hope that you find the joy in learning things like this, because you cannot enjoy mathematics if you are just memorizing. Some people are able to do well simply by memorizing. Okay, they remember anything power 0 is just 1 lah. They can do well, but I think the journey is more difficult compared to if you choose to understand. Okay. Zachary, the water bottle positioning very strategic. You know what I mean, right? You know what I mean? Do you know what I mean? You know what I mean, okay. Okay, next. Now, let's talk about negative powers. We have covered positive powers, 0 powers. Now let's talk about negative powers. For example, on page 9, okay, we've got 7 power 3 divided by 7 power 5. We know from our calculations, this will be 7 power 3 over 7 power 5. And we can fill in the blanks with our laws of indices. That gives us 7 power 3 minus 5, right? This is supposed to be 7 power negative 2. Can we do the same question with another method? Yeah, another method will therefore be 7 power 3 over 7 power 5. And I get 7 times 7 times 7 divided by 7 times 7 times 7 times 7 times 7. What should I do with this? What should I do? Yeah, cancel with your pencil. Cancel, 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 cancel. What am I left with? 1 over 7 squared. Right? Okay. Do I have the same question over here? Same question? Same question? So the answers must be the same, right? This must be the same as this. Get it? What happens if I change the number 7? Can I change it to 10 and will it still work? Yes. Yes. What if I change it to 999? Will it still work? Yes. What if I just change it to A? Will it still work?
Yes.
Yeah, A will just be any number. So here I will end up with all these are A's, and this will be A. Okay? Now, next question. We do know that, let me remove all other irrelevant things. We know that these two are meant to be the same. Okay, this is equals to 1 over A squared. What happens if the power, instead of 2, it is changed to something else? Let's say 21. What is A to the power of negative 21? 1 over A power 21. Easy or not? Because of the same logic, you can do the cancelling if you like. You cancel, 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 you realize that, hey, actually, this is our summary. A power negative n equals to 1 over A power n. Regardless of the value of A, regardless of the value of n. But there's a condition. A cannot be equals to 0, as well as n is positive. Why A cannot be 0? What? 0 power anything also 0. So why cannot? So why doesn't this work? No? Exactly. Do you hear what he said? You cannot divide by 0, right? If A is equal to 0, you have 1 over A to the power of something. I don't care what the something is, because you have all mentioned that A to the power of any number will still, 0 to the power of any number will still be 0. You divide by 0, you're going to get a problem. So A cannot be 0. Okay? Over here, n is positive. What happens if n is negative? If n is negative, then the power will become positive. Okay, let's just see what this means. I've got A to the power of n is positive, right? Negative, for example, negative 6. So this gives me 1 over A to the power 6. Right? This is how we know it to work. What if the value of n is negative? Then I will get something like this. A to the power of negative, for example, negative 5. Now my value of n is negative, right? It is negative 5. So I am going to end up with A to the power of 5. Correct? Yeah. Then what's on the other side? What do I expect on the other side? It is going to be 1 over A to the power of negative 5. Now, is there something wrong over here? Yeah. No, there isn't anything wrong. This simply is just telling us that, hey, A power 5 is actually 1 over A power negative 5 lah. Okay? But why you want to complicate things? Why you want to write things like this when you simply have A to the power 5? Okay? So it is not that n must be positive. It can be negative, just like this. You will end up looking something like this. Okay? Is there anything very difficult that you have just learned over here? Or are they small incremental steps that you have, small things that you have just learned? Small things, right? Okay, so we are going to progress this way. We teach you bit by bit, but you must make sure that you understand them. If you don't understand, you are going to lag behind. You're going to fall behind. And it's going to accumulate. At the end of the chapter, you will say, I don't know what's going on. Well, your friends do. Okay, so let's not get there. Okay, so let's go on to some simple examples. Okay, example 5a. 2 to the power of negative 3 plus 5 to the power of 0. They want you to evaluate this. What do we have? 2 power negative 3. You are not supposed to be using your calculator. That is the instructions. Okay? So 2 to the power of negative 3, it is a negative power. What shall we do with negative powers? How do we make them positive? Yeah, change it to a fraction, right? It becomes 1 over. Okay, plus 5 power 0 is 1, are you sure? Yes. Very good. What's 1 over 2 power 3? 6, sure not? 8. Okay, 1 over 8 plus 1, right? So that gives me 9 over 8 lah. Easy? Okay, is there any example in example 5 you want me to go through? Otherwise, we can go on to try it 1 already. Okay, let's go on to try it 1. I believe some of you would have already done it. Sorry, try it 5. 8, 5. Okay. A, B, C, D. Choose one for me to go through for you. B. Any objections?
No.
Okay, 5B. 5 power negative 9 times 5 power 6. You know, I got a feedback from your relief teacher that how come there are so many methods, so many ways of doing it? Simply because there are so many ways, you have the options. Doesn't mean one way is right, one way is wrong. Okay? So, can I have a suggestion? What do you think we can do over here? What can we do over here? Change to a fraction. Okay, let's change 5 power negative 9 into a fraction. What do we get?
1 over 5.
Then?
5. 5 to 1.
Okay, then what do we get?
5
Okay, 5 power 6 over 5 power 9. And what do we get?
1 over 5 over
1 over 5 power 3. And then?
1 over 5. 1.
Right? Hey, do you all memorize this now? 5 power 3. Do you all memorize it?
Yeah.
No? I think you should. It's going to be very useful.
1 to 5.
Okay? So this is one way of doing it. Is there another way of doing it? Can I have another way? Okay, slowly. One person, please. Okay, what do we have? Negative 9 plus 6. Okay, so I get 5 power negative 3. And then? 1 over? 5 power 3, which is 1 over 125. Yeah, that's it. Easy? Yeah, it's meant to be easy. Okay, we are all doing chapter 1 only. Okay. Next, example 6. Is there any that you... Okay, read example 6. Express your answers in positive index notation. Do you understand what that means?
This the power.
Yeah, the powers must all be positive. What happens if I end up having a negative power? For example, 6a. They do, then your answer is a power 6, b power negative 8. Is this positive index notation? No, I've got a negative sign over here. What should I do?
Move it down.
Move it down. Okay, that's an interesting way of putting it. B power 8. That's it. Can?
Yes.
What, just to test you, what happens if my answer looks like this? Equals to 10 over b power negative 6. Negative 8 8. Is this positive index notation?
No.
Sometimes you can do okay and end up with this. Then what should I do?
Move it up.
How do you move it up? What would this be equal to?
Remove the negative from the index notation.
Oh, you mean like this? 10 over b power 8?
Then move it up. Move the b of power 8 up.
Okay, so you're saying it looks like this now.
Yes.
Do you all know why?
No.
Who needs me to explain? Okay. Let's do it step by step. I've got my numerator as 10. I've got my denominator as b power negative 8, right? What exactly is this p power negative 8?
1 over b.
What exactly is b to the power of negative 8? 1 over b power 8. So I've got a fraction inside another fraction. You do realize that fractions are simply divisions, right? You realize that fractions are divisions, right? Okay, so what I actually have is 10 divided by 1 over b power 8. Yes? All agree? Do you like to divide a fraction? What did your primary school teacher tell you when you had to divide a fraction? 10 multiplied by? Over 1, right? But we don't want to write over 1 because we are all smart people. We don't need to write over 1, right? Okay, so this is 10 times b power 8. Can I simplify that? I simply remove the multiplier, so 10 b power 8. Okay, so in other words, 10 over b power negative 8 is simply 10 times b power 8. You keep doing this enough, you will realize that actually I can skip all the way over here. Which I believe some of you can do that already. The only way to learn maths is to do maths. But you must do with understanding lah. So you do and do and do with your understanding, you should not have problems. Okay, so next, try it 6. Is there a question you would like me to do for you? Try it 6. Any one question you want me to do for you? No, now you have time to look at it. If you are cool with everything, I shall move on. 6C, yeah? Did I say that? No. Then no need. Okay, so try 6C. 5x power negative 4, y power 8 divided by 15x power negative 3, y power 6 with brackets over here. Okay, there are different things that we can do. I would like to get rid of that division. How do I get rid of the division sign?
Keep the first inverted second.
Keep the first inverted second or simply convert it to a fraction, right? We are all very comfortable with that. So 5x power negative 4, y power 8 divided by 15x power negative 3 and y power 6. What did your primary school teacher tell you? Cancel what and what? 5 and 15. Okay. So cancel away the 5, cancel away the 15. I'm left with 3 at the bottom and 1 at the top, right? Can you see or not? Yes? No, I didn't record. Yeah, I didn't record. I have only recorded the first 16 minutes. I didn't realize it. I paused it for a while and then I forgot to resume. So let's resume from this part. Anyway, you should be paying attention in class, okay? Next, what about things like this? A power m over n. What does this mean? Can I split the fraction?
Yes.
I can, right? I will get a power m power 1 over n, right? Is this correct?
Yes.
Because if I expand on the right hand side, I just simply have to multiply them together. Is this the only way to do it?
Oh.
Alternatively, I have a power. Sorry? Okay, do the root first then, like this. Agree that they are the same? Okay. Now, a power m is simply a power m. There's nothing I can do about it. But what about this 1 over n? Root it. Which root is it? Nth root. Okay. So I've got a power m and I n root it. So you need to recognize that these are the same. Okay. No need to memorize. Understand it, use it. Practice, it will stick with you for life. And on the other side, same thing. I can always do it part by part. A power 1 over n is the same as, what is inside the bracket? What's inside the bracket? Nth root of a, isn't it? And on the outside I have power m. So these are all equivalent. You need to know this. They're all the same. So when I change your questions, okay, you could have numbers instead of a. You can have numbers instead of m. You can have numbers instead of n. Just substitute accordingly. Okay? So homework questions are already in my video, which you can watch online. There should not be any lag at home. We can now move on to try it 8. Is there any part of try it 8 you want me to go through? Or do you think it's too easy? Or do you want some time to do it?
So I haven't even seen the question yet.
Okay, try it 8. Take a look at the question. Press record now. Try it 9B. If you think you want to attempt it yourself, go ahead. X power 3 over 2, y power negative 4 divided by x power 5 over 3, y power negative 9 over 2. So complicated. Right? No? Is it complicated? No. What shall we do first? What shall we do first? Change to a fraction, yeah, because I don't like the divide. So x power 3 over 2, y power negative 4 over x power 5 over 3, y power negative 9 over 2. Did I change the powers? Did I change any power? No, I didn't. I simply placed the whole right hand side as the denominator. Okay? So now, my next step, what do you think I should do? What should I do? You want to start with x or you want to start with y? Or do you want to change the negative power to positive power?
Positive power.
You want to change to positive power?
Yes.
You can, but you are giving yourself more work. You can, it is not wrong, but you are giving yourself more work. But I don't like to waste time. How about I use my second law of indices, which says a power m over a power n is simply a power m minus n. There is no restrictions. There are no restrictions that says m must be positive, m must be negative, so on and so forth. We never say that. As long as you have a power m, m can be any number, divided by a power n, n can also be negative number. Simply minus the values. Okay, so let's start with x, shall we? What is the power for x?
3 over 2.
3 over 2. Is that all?
Minus 5 over 3.
Agree with the x terms? What about the y terms?
Y minus 4.
Negative 4
Plus.
minus.
Plus.
Or you want to change the plus, okay? I prefer to put minus negative 9 over 2. Is there anything mind-blowing so far?
No.
Compare these two steps. Is there anything that is very difficult or very unique? Something you have just learned only? Is there?
Not yet.
No, right? Still quite straightforward. And that is what it is meant to look like. So now it becomes, we have reduced the problem to one that is simply fraction minus fractions. Primary school can do it, right? You also can do it. 3 over 2 minus 5 over 3. Lowest common denominator. Or use your calculator if you want to. So what do we have?
Negative 1 over 6.
Negative 1 over 6. I assume you're right, huh? And y to the power of? 4 plus 4.5. Sorry, negative 4 plus 4.5. Okay, power half. Is this my final answer? Why not?
Negative index.
Oh, they wanted it to be positive index, right? So what shall I change?
Negative.
Only the x, right? So how do I change it to positive index notation? Fraction. What do I write as the numerator? 1 over 1 over x to the power 1 over 6. And on the other side, I have y to the power half. Okay? I can put it this way, y power half over x power 1 over 6. Do I have positive index notations now?
Yes.
Yes, I do. Do I need to rewrite y power half as a square root?
Maybe.
Do I need to? Okay, my question is, must I do this? Equals to square root y over 6 root of x. Do I need to do this?
No.
No need. No need. But you must know that they are equivalent. They are equivalent. They are the same thing, but you don't have to do this. They only ask for positive index notations. Okay, and that's all for 1.3. The homework questions, please go and look through them. Look through the video to see the questions that you have to do. By right, these questions